Okay, today we're going to talk about objects. So we're going to talk about the core data types in objects for the first section of this class. And then we're going to talk about the collections for the second section of the class. And we're going to move to control flow. I think if we work through core data types, collections, and control flow, you guys will be sitting in a really good spot to write some non-trivial Python programs. So it'll be an exciting spot to be in. Objects. In Python, everything is an object. I think by the way, somebody has a fire detector background, I think low battery noise. So in Python, everything is a object. So all of the data types that you work with, all of the functions that you're going to call, all the classes that we're going to learn about, everything boils down to an object. So what is an object? Everything including integers, strings, lists, attributes, methods, or objects. Objects store data and have associated behaviors with them. Just like when humans like to name things. We like to put things into boxes so that we understand them. So there's animals in the world, and we like to put names on animals because they behave different than other animals. Maybe a lion is different than a bear. They have different things that they do. They have different attributes about them. And the way that we represent that in programming is through objects. This is not the same thing as a variable. A variable is a name that we attach to something. So maybe I'm Emily and I'm of type human, but a variable for me is my name. So my name is Emily, and that's how it's stored and referenced. So the way that we reference and we call these different objects is through variables. So you can have many different bears or many different tigers, and maybe you want to have an individual name associated with each bear or each tiger. That would be a variable. So a variable is how we name and refer to these objects that are stored in memory. And variables are dynamically typed in Python. That means that we don't have to say explicitly, I am going to call, create a new variable, a new integer and it's of type int. We just say new numbers equals, and we pass a list. And in Python, it infers that it's a list. So Python objects. Everything's an object in Python. An object in Python is something that represents a specific piece of data or functionality. So over here we have object land. This is a list and it has some numbers in it, 2, 1, 3, 4, 7. This is variable land. The name for that we're going to use to refer to this list, because we don't want to say every time we want to use a list, we don't want to say, hey, that one list says 2, 1, 3, 4, 7. Instead, we create a name, a way to reference and refer to that list. So this is the variable. The variable is numbers, and this is the object that variable is pointing to. The variable is numbers 2 here, and the object that variable is pointing to is list 11, 18, 29. So everything in Python is an object. We have variables that allow us to reference and call those objects and retrieve them from memory. Identity, type, and value. Every object in Python has 3 key components. It has an identity, a type, and a value. An identity is the unique identifier for an object. We have to have a way of telling one object different from another object, a way of differentiating one object from another object. That's our identity. Type is how we're going to tell what the functionality is associated with that object. So we want to ask, is it a tiger or is it a bear? In this case, we're running type on Alice, and we're seeing that this is a string. And there are certain things we can do with a string that maybe we wouldn't do with an integer or can't do with an integer. And then value is the information that's actually the data that's actually stored in this object. So Python's core data types, we have numerical types, Boolean types, and text types. Numeric types in Python that are the core data types are integers and our floats. So the integers represent whole numbers. Anytime you see something that has a decimal point, that's going to be a float. So Whole numbers are integers. Floats have decimal points associated with them. The other data type we're going to talk about today are Booleans, which represent true-false values. When you guys learned about operators, like equality operators, or you're already familiar with the true-false values that come as output from this. And if you're working in Google Colab, it provides this nice little function for you where you can see that the Boolean type is actually highlighted blue. So it differentiates that, yep, this is a keyword when you use that. The other Python core data type we're going to talk about are strings. And strings represent text data. So oftentimes we have to create a program that uses strings. Numbers aren't enough. If you're creating an application, you want it to actually take input from a user. So we need some string values here, and this is how that's actually represented. So we're going to talk more about these. We're also going to talk about Python collection types. So these are the core data types, and Python collection types we're going to talk about are lists, tuples, and dictionaries. So having just one-off numbers isn't enough. Sometimes we want to group things together so that we can do things like iterate over them. Maybe you want to create a shopping list. You want to create a shopping application. So we create a list of apples, bananas, and cherries, and pass that and continue to add to that list as we find more things that we need to add to it. So there's value here in lists, tuples, and dictionary. Tuples are immutable, lists are mutable, and dictionaries are key value pairs. Okay, each of these objects have attributes and methods associated with them. So objects come with some functionality that we can apply. Attributes are stored data associated with this object. So an attribute would be it's a bear, and how many legs does this animal have? It has 4 legs. So that would be an attribute. Attributes tell you something about the object. Methods, on the other hand, are functions that you can call. This over here is a function we're calling text.upper. Functions do something. So we're calling text.upper. Upper is the function. Let me just get my pen out here. So text is our variable. This is our variable, our var. Hello is our string object that we're actually storing into the variable text. Now, anytime that we refer to text, we're actually referring to, it's the same thing as saying hello.upper. So we're calling, the output of this is going to be hello, where it's going to uppercase each of the letters. This is a method. This is a method that we can call on strings. So it's a string method, which is different than methods that we have for lists. I think the point that I'm trying to make here is that what is an object? Why do we have objects? We have objects because they have different attributes and different methods. If we look at a list, for example, we have the var here. Our var is now called myList. And now this is a list object. So here's our object, our list object that's being stored in memory. And we're going to call .append. And we're going to pass a value of 4 to that. And that's going to add 4 to the list. So if you look at the output of this, it's actually going to be 1, 2, 3, 4. So we added 4 to this list. So what append does is it takes in an integer and it adds it to that list and saves that back in memory. Mutability. So there are, earlier I said there are things that are objects that are mutable and objects that are immutable. What does that mean? What does mutable and immutable mean? When an object is mutable, it means that it can be changed, such as lists. So what that means is we have our memory here, and we have our variable name that we're assigning to this. And we have we called this my list. This is going to be hard to. And we attach this to 1, 2, 3. Now we're adding 4 to it. So we're going to get rid of that. And my list now is 1, 2, 3, 4. So we can change it. Mutable just means that we can update and we can change this object. Some other objects are immutable. Immutable objects cannot be changed, such as strings. So strings are immutable objects. When we create a variable text and we assign it the value of hello, and then we can't change that. So if we call text.upper, it would actually uppercase hello, but it wouldn't save that back in memory. And I kind of want to draw this out. This may take a minute. So if we have text and we assign it the value of hello, I'm going to draw this out, and then I'm going to open up a code notebook and actually show you this, because it is I think it's helpful to understand objects and the mutability component. So we have this text hello. If we then call this text.upper and it outputs hello, it doesn't actually change this. So we're not actually changing the value. So let's look at that. Let me see if I don't know if I'm doing that in here or not, but we're going to do it right here. So we have text equals hello. Okay. Let's see what text is. It is hello. If we call text.upper, we get hello output. But if we look at text, we see that the stored value of that variable in memory is still just hello. It didn't change to be uppercase. If we wanted
need to put 1 in the upper to show that we're saving 1 value, or without anything, it assumes that it's 1? Oh, okay.
If we put 1 here, let's see what this error, string.upper takes no arguments. So we're not looking to pass any arguments to this this function here. You know this is a function, by the way, because it ends in parentheses. But yeah, that's a good question. On the other hand, let's look at so this is a immutable object. Let's look at a mutable object. A mutable object is something like a list. Let's call mylist.append. So mylist equals 1, 2, 1, 2, 3. Oops. Okay. My list, we can see that it is 1, 2, 3. Let's append. Let's add 4 to the end of the list. Now let's print my list. Oh, and we see that 4, in fact, did get added to the end of the list. It actually changed the way how that object is stored in memory. We have a new line now pointing to that new updated information. Whereas with text, if we wanted to save that uppercase information, we'd have to create a new variable. We could call it text, but if we called it text, it would overwrite the other variable. So this is the difference between mutable and immutable. I've mentioned a couple times that variables are dynamically typed in Python. What does dynamically typed mean?
Emily?
Yeah. Yeah.
Emily?
Yeah.
It's Celeste.
Can you hear me?
How do you tell the difference? How do you tell the difference between whether something is mutable or immutable? What cues you? What cues you?
That's a great question. I would say a two-part answer here. The first part is that I will define for you what types of objects are mutable and immutable. That's what we'll define in the slide. The types of objects that are mutable and immutable. Generally speaking, if you're curious, you can either just look up, is a list mutable? Is a tuple mutable? Is a tuple immutable? But if you want to experiment and like play around and see if it is mutable, you could try calling a method on that list and seeing if it updates. But I would recommend just looking up or knowing which data types are mutable or immutable. It won't change. So if you're working with a list, it will always be a mutable list. Does that help?
Okay. Yes.
Okay, perfect. Good question. Okay, dynamic typing in Python. Variables in Python don't have predefined types, I guess is a better way to say that. So their types are not fixed. We can cast them, meaning we can change them to different types. So Python's dynamic typing makes it really flexible, but we have to be careful of typing. So let's do that X example. Let me see if I have that in here. I do. Okay, dynamic. Okay. Yes, I have all these exercises in this notebook. So dynamic typing in Python. So if we have X equals 10, and we want to see what is X. Remember I said objects have types associated with them. We want to see what type of thing is X. We can call type X. So that's TYPE, and then that open parentheses, the variable that you want to assess that on, and then close parentheses. And we see that it's an integer. Now we can overwrite X. We can say X is equal to hello. And we can run type on that. And now X takes on the value of a string. So we can overwrite that variable. It's no longer an integer, it is a string. So you have to just be a little careful in your notebooks. If you're using the same variable name, you may overwrite it essentially. And that's one of the features of dynamic typing. Okay, so all of this is to help you think about objects, because we're going to start defining types. And I think it's helpful. There's two ways to go. We can either go bottom up or we can go top down. We can just start trying stuff and playing with Python programming and then figuring out how all these things fit into the world, or we can start top up. And that's what we're doing, is top up. We're figuring out what is an object. And now we're going to go look at types and figure out what types are. So think of objects like tools in a toolbox. You have a screwdriver and it has a type and it has a very specific purpose and a thing that it does. So we're going to talk about integers. What is an integer? What's its purpose and the things that it does? And it has a brand and a size, which could be attributes, characteristics about it. And you can use it for tasks. You can twist the screwdriver. There are methods and tasks that you can apply to it. So similar to that, objects in Python, they have types, they store data, and they have methods to work with that data. So let's practice capturing the type of these different variables. I want you to spend maybe just a couple minutes, 2 to 3 minutes, and declare a variable for an integer in your notebook. Open up your Colab notebook, declare a variable for an integer, 25, declare, and then run type on it. If you can either print type, or you can just spell out type and pass that variable. I want you guys to practice. Tell me what, try to get this to output the type for 25, get it to output the type for 3.14159, get it to output the type for Python rocks. The same for this list here and the dictionary. All right, 2 to 3 minutes. 4:33, or I'm sorry, 6:33. I forgot I was on one screen. I'll leave this up. Okay, I'm going to start to, let's practice our variables and types. If we do type on 25, we're going to get int. If we do type on 3.14159, we're going to get float. If we do type on Python rocks, we're going to get string. If we do type on apple, banana, cherry, we're going to get list. If we do type on name, John, age 30, we're going to get dict. So that's a dictionary. What do these mean? What does int, float, string, list, dictionary mean? That's what we're going to talk about today. Sorry, say again.
They're object types.
Oh, yeah, there you go. That's exactly what they are. They're the object types. So these are the types that these objects carry. So key takeaway, everything's an object. Yep. I talked about a lot of high-level stuff. I brought that to you guys because I think it's useful. What do you need to know from all of that content? Know that everything in Python is an object. That objects store data, and we have methods that interact with that data, and that there are types. So that we're going to talk about here. The first one is integers. 1, 2, 3, 4, 0, 5, negative 42, 1, 2, 3, 4, 5. Integers are whole numbers. They can be positive or negative, but they do not have decimals. In Python, integers are represented by the int data type. So you saw in that notebook, it said int. That's the data type that it's represented by. Int is the data type used to represent whole numbers, both positive and negative, include 0, and it's a built-in type in Python. Some key features of integers is that they're optimized in Python and they're faster to work with compared to floats for operations that don't require decimals. So integers should be kind of your default data type that you go to. There's unlimited precision. Integers can be as large or as available as the memory would allow. They are dynamically typed, meaning you don't need to declare the variable's data type explicitly. We don't need to say, I'm declaring an integer. We just said big number equals, and the program infers that this is an integer. Int objects are immutable. That means once it's created, they cannot be changed. So when we use our operation, our plus equals operation that you guys have already learned about, it actually creates a brand new integer object and overwrites that. So we're actually recreating the variable x and the object location that it's referencing every time we use the plus equals. There's not a lot of built-in methods with integers. There's not a lot of methods that we call on them. However, one interesting thing that we can do with integers is we can cast. So casting is a programming term that refers to the process of converting one variable to another variable. So if we have something declared as x equals 10 and it's a string, and we want to cast it to another variable type, we want to cast it to an integer, we can call int, open parentheses, the variable, and then close parentheses. So Python provides built-in functions to explicitly cast and convert and change data types from one to another. This is really useful when working with input from users or calculations. If you're saying, hey, give me some input, you may get that input in a string. When we cast, it's truncation, not rounding. So if we cast 4.9, the output of this is 4, not 5. So we're just cutting off the decimal point when we're casting a float to an integer, as opposed to rounding that up. One thing to note, we're not going to be able to convert things that don't make sense. So Python, the programming language of Python is kind of smart, but it really doesn't know what to do with the word hello. So what am I supposed to do? How would I convert hello to an integer? Let's look at this. Oh, those were my type things. So if we run type on 0, that's an integer. If we run type on 5, we can see that's an integer, negative 42, 1, 2, 3, 4, 5. I guess that's 12,345. And integers are dynamically typed. We don't have to declare it. I want to look at this. See if I already have it. Here we go. So this y equals 10 here. If we have x equals 10, maybe we took some input from our user. What would what do I mean? Maybe we took input from our user, like this, input. So we said, hey, enter a number. So input is a function you can use in Python that prompts the console for you to do something. And so we said we want to provide this text in the front, enter a number. So that's the prompt that we provided. So we're going to enter 10, and we're going to store that value back into number. If we print out number afterwards, I'm going to have to re-enter this because I reran that. we can see that it is, if we do, so we saved this, so we still have a variable number. And if we run type on number, we can see that it is of type string. So this is a string value, and it's one of those scenarios like we were talking about in that slide where we want to convert this to a number, because maybe we want to add 10 to it. Maybe we want to multiply it by 5. We want to apply some mathematical operations. If we just said number plus 5, we're going to get can only concatenate string and not int to string. So the program doesn't really know what to do with this, because our number, our value of 10 that we're trying to work with is not a integer. So we need to cast it. So to cast this to an integer, we would say int number, and that would cast it to an integer.
Wait, what did casting do in that case?
So in this case, and I want to, in this case, it cast it to so if we ran type on this of our int number, we can see that it cast it to an integer. But remember, we said strings are immutable. And so we didn't actually cast the saved object as an integer. So if we, hold on. So we called int on number, and we changed it from a string to an integer. So it was a string. We changed it to an integer now. We cast it to an integer. Give me just one moment here. I am getting a phone call. One moment.
Oh, we just changed it from one to another. Okay, that's what you're saying. It was a string. Yeah, answer your phone call and then we can talk.
Okay, give me just one moment. I apologize. Thank you. I apologize. Okay. So what we did here, let's just orient. Let's start at the top here. We have a number. We took a number from our user. We took the number, let's just change it. We took the number 8, and we see that number holds the value of 8. When we run type on that, that's a string. And maybe we want to do things with it. Maybe we want to call number plus 5. But we can't do that because it's a string. So we need to convert it to an integer, because it should be an integer. If we call int on number, int open parentheses number, it converts it to a integer. We can kind of tell that it's an integer because it doesn't have these little ticks next to it. But if we wanted to verify that, we call it int number. And we can verify that indeed calling int on number does cast it to a type int. The thing I want you to be aware of is that we did not save that back in memory. So if we call type on number, again, on a different line outside of the execution that's happening on this line, we'll see that it's actually still a string. So what we would have to do is actually say number equals int of number. And now if we call number, we see it looks like an integer. And if we actually check the type on it, yes, it is an integer. Okay, did that help answer your question?
Yes, we're just changing from one type to another.
Exactly.
By specifying that's the casting. Okay, got it. Thank you.
You got it. Okay. There is implicit casting versus explicit casting. I just want you guys to be aware of this. This isn't something we need to spend too much time on, but Python automatically converts between compatible types when needed. So if we have result equals 3 plus 2.5, and we print results, this was an integer, this was a string, or was a float. And now if we print result, we're going to get an object of type float. So that's implicit casting. It already cast. We can add floats and integers together because Python has implicit casting. Explicit casting is what we did. We actually explicitly cast something that was a string value into an integer so that we can apply operations to it. FYI, there's int versus integer. What's the difference, int versus integer? Integer is the term used when in some other programming language like Java, C, Sharp, and .NET. I just want you to be aware that if you see the integer keyword and you're confused about the difference between int and integer, int is just essentially the built-in data type and the syntax that Python uses. Okay, you guys try it. Let's assign the number 25 to a variable x and print its type. Oh, we already did type printing. Oh, we're going to do some casting. So assign a number to 25, variable x, print its type. Assign the value 3.7 to variable y and convert it to an integer. And then assign the string 42 to variable z, convert that to an integer, and try converting the string hello to an integer. What happens if you try to convert the string hello to an integer? Let's spend 3 minutes. So 650. I'm going to keep doing that. Apologize. Okay. A couple more minutes here. All right, let's try to do this. If we assign the number 25 to variable x, so assign the number 25 to variable x and print its type. Let's assign the value 3.7 to variable y and convert it to an integer. We should probably assign that back to y. And print y. Great. Let's assign the string 42 to variable z and convert it to an integer. We should probably assign that back to z. And let's print the results. 42. Okay, let's convert the string hello to an integer. What happens? Oh, we got an error. The program doesn't know what to do with the string hello. Okay. Let's talk about floats. Any questions on integers? Okay, let's talk about floats. Floats.
So I have a quick question. So
Yeah.
if the number, if we already have an integer, we could start as a string, or we can cast it into an integer. But if it's a non-integer, like some junk like hello, we cannot cast it into an integer, right?
That's right. So the program doesn't know what to do with the string hello, or it doesn't look or feel like what it would expect to be an integer, and it doesn't know what you want it to do in terms of like how to represent the string hello as a number.
Okay.
Yep. So it has to be somewhat intelligible for it to convert.
Sounds good. Thank you.
Floats. Floats represent numbers with decimals. So 3.14, negative 0.5, 10.0, 0.0 is a decimal. Floats are commonly used for calculations that involve fractions, decimals, precise measurements. Floats store the approximate values for decimals. So there's kind of an interesting exercise you can do where we can be off just a little bit due to decimal point precision. Scientific notation, I want you guys to be aware that sometimes you'll see 1.2E5. That is just scientific notation representation of decimals. Operations. Floats support basic operations like arithmetic operations, addition, subtraction, multiplication, division, and just like with integers, we can cast them. So let's look at the casting. Just like with integers, we can cast our floats. So we have a x equals 10, and we know that that's an integer because we can run type int on it, and we can see that it's an integer. We can actually cast that. We can print the float of 10. So if we call, actually let's type. So that is a float. So we can cast from an integer to a float. We can also do that with the value 3.14. So if we cast 3.14 to a float, that was a text, we're going to get that float output here. And we can actually cast true to a float as well. So trues can be are represented as ones, and falses are represented as zeros. Okay, we're going to keep going. I don't think we need to do the try it for floats, but we will for Booleans. So Booleans represent one of two possible values. So I think integers are pretty intuitive. Floats kind of make sense. There's some different things we want to do with floats from integers. Then we have Booleans. Booleans represent one of two possible values. They can either take on the value of true or it can take on the value of false. And Booleans are immutable in Python, so you cannot change them. They're used to make decisions within a program. So the origin is that they're named after this mathematician, and they're commonly used in comparisons conditional logical operations, as you guys already know. Some key features of Booleans is that they are case sensitive. So we talked about how it has to be the uppercase T, lowercase RUE. They're used in logical operations. Casting to a Boolean looks like calling bool. So we call bool on 0. That converts it to false. We can call bool on 42. That converts it to true. When doing casting with a Boolean, false values are 0. Everything else becomes true. So anything from a numerical perspective. So if it's 42, it's true. If it's 1, it's true. If it's 53, it's true. Converting an empty string evaluates to false. Converting a string that has any content in it at all, converts to true. Okay, so internally, true is represented as 1, false is represented as 0. So we can do funky operations here. Let's look at that. So internally, since true is represented as 1 and false is represented as 0, we can actually do true plus true. We can actually add trues together and we get 2. And we can do false times 10, or we can do true times 10. And we're actually going to get 10. It's going to take 1 times 10. So I think that's a useful feature to know, that Booleans internally are represented as 1s and 0s, since there's only one of 2 outcomes. So the impact of that, representing things as 1 or 0. So in Python, Booleans are either true or false. They're essentially, under the hood, true is represented as 1, false is represented as 0. And just to lay some context of machine learning in here, Booleans often play a really integral role in our data processing, in our data model design, and evaluation. So as you get into the machine learning class, you'll see that we label outcomes as did it happen or did it not. You're selling a house, for example. Did the house sell or did it not? You're trying to make a sale to a new customer. Did they buy from you or did they not? They're usually represented as 0s and 1s. And we actually train our machine learning models to predict the 1s, to predict the signal, what's called the signal or the outcome or the target variable. So the Booleans play a really important role in machine learning and the target variables that we create. Okay, you try it. Assign true to the variable is raining and print the type. Write a comparison that evaluates whether 15 is greater than 10 and prints the results. Write a comparison to check if the Python string is equal to Python. And I think you'll find that it's case sensitive. So spend 2 minutes. And then we will do strings, and then we'll take a break. sorry, getting into strings. Okay. Assign true to the variable is raining. In Python, when we're creating our variable names, we can't put spaces in them. So if I tried to do is raining equals true, we're going to get some type of syntax error there. And print the type. So there's our type. Let's write a comparison that evaluates whether 15 is greater than 10. So is 15 greater than 10? And print the result. And write a comparison that checks if the string Python is equal to Python. And that's false. Okay, strings. This is a string, and so is this. What are strings? String is a sequence of characters enclosed by quotes. They can be single quotes, it can be double quotes, or it can actually be triple quotes as well. So for example, hello, Python, this is a string. These are all strings. You can think of a string as a case-sensitive sequence of characters. So whether or not it's a capital H does in fact matter. Letters, special characters, digits, all of these things are included in a string. Strings store a series of values. So we can iterate over a string. They have positional indexes. We can do for I in this text, where this text is the string. We can print I, and we see that each time it prints another index of our string. Strings are immutable objects, meaning their value cannot be changed after they are created. And what if we need to change the string? So if we need to change the string, we can modify the string and create a new one. So we can say text equals Python, modified text equals text.replace P with J, and then we can print the modified text versus the original text. A couple of key features about strings, we can have multi-line strings. We can do string slicing and indexing, where we can extract parts of a string. So if we say text at 0, this will just pull out the P. If we say text 0, position 0 through 3, so in Python everything is 0-based, it's a 0-based index. So instead of starting at 1, it actually goes through 3. So starts at 0. Sorry, I was trying to grab this pen. So strings have indexes. So this is 0, 1, 2, 3, 4, and 5. So this is the 0th position index, and the string, if we're slicing 0 through 3, we're actually going to get PYT. It's exclusive. It starts at 0. And it ends at 3, but is not inclusive of position 3, so not inclusive of the H. So slicing and indexing, we talk about that more later. I just wanted to add that context. Casting for strings, we can cast. Common string methods. Now, strings have some pretty useful methods associated with them. There are things that we can do to strings that maybe we don't necessarily need or want to do to integers, or don't need or want to do to floats. Like we can uppercase the strings, we can lowercase strings, we can remove white space from strings, we can replace parts of the string. So we can call string.upper, call text.lower, text.strip to strip out white space. Concatenation is when we add two things together. Okay, maybe I should have talked about string. I didn't realize string indexing was this next slide. So indexing in Python means accessing something, and then strings have string indexing. And this is when we access individual parts of the string using something called their positional index. In Python, everything is zero-based. Python is a zero-based index language. I would say that's a really important key thing to remember about Python. It's kind of an iconic part of the language. And so the first character starts at 0, and it goes up sequentially. Negative indexes, we can start from the end of kind of a clever thing that they did in the Python language is that you can start at the end. So if we call text at -1, that'll actually give us n. We can start, if we call text at -2, that'll actually give us 0. We can start at negative indexes. String slicing is when we extract a portion of the, I'm realizing I should maybe open up our workbook here. And let's look at this a little bit before we get too far. So what is a string? Let's go to let's go to string indexing. Here we are. Indexing and slicing. So if we have the text Python, and we print, we want to see what text at 0 is. That's going to be P. Text at 1 is going to be Y. Text at 2 is going to be T. Text at -1 is going to be N. Text at -2 is 0. So we can either go left to right, positive indexes, or we can use the negative numbers to start at the end. So string slicing is when we extract a portion or a substring using a range of indexes. So we have a start and an end. So start, end. So this is where we start. This is where we end. The starting index is usually inclusive, and the ending index is exclusive. So we include the starting index. We go up to the end index, but do not include it. And we can also use a step value. The default step value is 1, but if we wanted to add, jump by 2s, we could add a step value. String, any questions on slicing, string slicing? Okay. String concatenation. String concatenation is when we're combining things together. So we can actually add strings together. It doesn't happen the same way that we would add numbers together for math. But string concatenation of the words John Doe would look like this. We have the first name is John, the last name is Doe, and we want to do first name plus, we're going to use the plus operator, a string plus operator last name, and the output of this is John Doe. Okay, what do you guys think is wrong with this code?
Shouldn't age be in brackets?
Let's try it. Oh. I'm just going to try it right here. Let's try age equals 25 and message equals I am plus age plus years old. And we get this error. Can only concatenate string and not an int. So you said put age in brackets like that?
No, this is quotes like
parentheses.
Parentheses, sorry. Yeah.
Put age in parentheses like this?
Mm-hmm.
Oh, we're still going to get an error. That was a good guess. So the issue here is that we're trying to concatenate a string. So we're trying to take something that is a string, an object that is a string, an object that is a string, and we're trying to add an integer to a string. And that's not going to work. So we're going to have to cast this to a string. And then we can get I am, well, if I had a proper space in here, huh? There we go. I am 25 years old. Okay, string repetition, just a useful thing to know that if you use the star operator on a string. So this is, I'm trying to bring the context of what we talked about with operators and how you can apply operators. You can apply operators to strings. If we did Python my string times 3, it will actually repeat that. It will multiply, give us that string multiplied by that many values. We can make it a little more intelligible by putting a space here. There we are. Okay. Do you guys think this will work? If we say text equals hello, and then we print text times 3.5.
I don't think it'll work.
I don't think so either. Let's try it. Nope, because we can't multiply a sequence by a float. The program doesn't know how to multiply by 3.5. Imagine if it was 3.873. It doesn't know how to parse 3 point some decimal in terms of multiplication. There's some things, what I'm trying to explain here is there's some times where, yes, we can multiply by text by a number here, but you may find some cases and scenarios where that's not going to work. Okay, so what is a method? A method is a Python. I want to talk about string methods a little bit. And I realized before we talk about string methods, I should probably describe what is this word method. I've been using the word method for a little bit. We should probably add some definition parameters around that. A method in Python is a function that is associated with an object and it operates on that object. So essentially, it's a function that belongs to that specific data type, and you call it using dot notation. So this is dot notation. That's why the period is here when we call that method. So text dot upper. Upper is the method that we are calling. The upper method belongs to this text object, or I'm sorry, the string object, which with the variable name of text. So the methods are tied to a specific object type, such as a string, a list, a dictionary, and it works on that object. A method is designed to manipulate and retrieve information about that object. It may return a value, or it may return no value, and it requires these parentheses. So that's why you see, it's a method if it has these parentheses, the open and close parentheses. So here are some string methods. Let's look at a couple. And like I said, you can tell because they have these parentheses afterwards. Lower, upper, capitalize, title. These are things that we can manipulate to a string. So if we have this text, hello, we're going to create some text, hello. If we call upper on that, that's going to uppercase if we call lower on that, it's going to lowercase all of that text. So our output is going to be hello. If we call upper on that, it's going to uppercase all that text. So the output is going to be world. If we call capitalize, it'll capitalize the first character to uppercase. And if we call title, it'll actually capitalize the first letter of every word. So we get the output of Python programming. a function, there are two things, two different concepts here in programming. These are kind of object-oriented programming concepts, by the way. I'm speaking generally to these now, so then when we come back next week, we're going to focus on packages and data visualizations and how to use Python packages. When we come back to object-oriented programming in week 3, a lot of these concepts are going to resonate with you. So a function is a standalone block of code that does something. So print function, you'll hear me say print function, the length function. Those are standalone things that don't belong to an object. The length function does not belong to the string object. The length function does not belong to the integer object. We can call length on string or integer or many other functions. So these are functions as a standalone block of code. And in week 3, and probably before week 3, you guys will actually create your own functions. A method, on the other hand, is a function that is associated with an object and it's called on that object. So upper is a method that's called on the string object with the variable named text here. So a method is actually associated with a object. Strings have their own string methods. So here's an example of a string method, or here when we're getting length, I'm sorry, I should have called this function. This is the length function. We're applying the length function to text. If we want to get the length of text, it's 14. Oh, I thought I had a string. Sorry, so these are the string methods. So that's why I was describing the difference between method and functions. These are the methods associated with the string that we talked about and covered. So not all of them, there's more, but here's a couple of very useful ones. String.lower, string.capitalize, string.title. Okay, I have a question for you guys. Here's a you try it. What is the value of S1 and S2? So let's start with S1. What's the value in S1? Okay, well, we have B is, we see that S1 is equal to B. What is B? B is equal to colon, so it must be colon. And then we're concatenating, we're applying string concatenation to C 2 times C. Let's see, this colon, and we're going to do it twice, so it's probably colon, parenthesis, parenthesis. Let's try it out and see. I'm going to get to the end of strings here, and then we're going to try it out. Okay. B is equal to C is equal to parenthesis. S1 is equal to B plus 2 times C. Let's print S1. Yep, there we are. S2, F is equal to A. G is equal to B. I'm sorry, space B. H is equal to 3. S2 is equal to F plus G times int of H. Oh, G, sorry.
That's G is equal to B, not B is equal to B?
Perfect. You got it. I appreciate that. I make those little mistakes all the time. S2. All right. So we did f plus g. So we have f is a, and g is space b. So we added those a space b together, and then times int of h. So we converted h to an integer, this 3 to an integer, and then we took that times 3. So we got that repeated 3 times. Just trying to give you guys some intuition for how some of this code works. Let's take a 10-minute break, come back at 7:20, and we will do the next set of slides here. So 10, I'm going to stop screen, 10-minute break. All right, and we are back. I am excited for us to get into control flow because control flow really allows us to start to do interesting things with a program. So prior to this, we just talked about how do we define data, define numbers, define strings, store them into objects. Now we can start to actually work with something. We can start to work with control flow to actually have direct how our code executes and in which order it's executed. So we can use conditionals, if, elif, else. We can use iteration statements like loops, using for loops and while loops. We can use jump statements, break, continue, nested loops. Each of these, and we'll go through these in examples. So let's start with conditionals. We're going to talk about conditional statements. In Python programming, we can use conditional statements to make decisions. So if a condition occurs, then execute this block of code. Elif, another condition occurs, then execute this block of code. Otherwise, execute this remaining block of code. In order to write useful programs, we really need the ability to check different conditions and change the behavior of our program accordingly. So the purpose of conditional statements is to execute code based on whether a condition is true or whether a condition is false. So the if statement. So here we have if, elif, and else. Let's go through each of these. The if statement. The Boolean expression if is called the condition, and if it's true, then the intended statement gets executed. So if this is true, then we execute the code in this block. Something about Python. Python's a indentation-based language, so the indentation here really does matter. If we, and we'll talk about that a little bit later. So if it's true, the indented statements get, I guess we'll talk about it now. If it's true, the indented statements get executed. So this print 1, print 2, print 3 get executed. If true, which true is always true, print 1, print 2, print 3. If it's not true, then nothing happens and the code continues. So not all of your code in your program might be executed. If that statement is not true, then that code will not execute. There's no limit to the number of statements that it can appear within the body, but there has to be at least one. And Python relies on tabs or 2 spaces to indicate that this is executable in the body. There is a pass statement, which occasionally it's useful if we have a body with no statements, usually as a placeholder if you haven't written any code yet. So we can say if x is less than 0, we can say pass. Pass means that there's no code in there. It's kind of a placeholder because we haven't written any functionality to put in there. The else statement is, so here we had if this condition happens, then do this. We can have the else statement, else do something else. This always follows an if. So we have to have an if in order to have an else statement. It's our alternative execution. It's what we want to happen in the event that this is not true. So if x modulus 2 is equal to 0, you guys remember modulus operator tells us the remainder. So if the remainder is 0, essentially if there is no remainder when dividing by 2, then print x is even. Else print x is odd. So if the condition is false, if x modulus 2 equals 0 evaluates to false, then we jump down to the else statement. So these are alternative branches, and it really controls how the program flows, and it controls the execution of the program. We can also just build on this concept. So we can start with if, else, and we can continue to build on this concept. So we can use elif. Sometimes there are 2 or more possibilities when we need to have sometimes there are 2 or more. This must have been notes from last time. That's really why that's crossed out. Sometimes there's 2 or more possibilities. So if x is less than y, then print x is less than y. Elif x is greater than y, print x is greater than y. Else, print x and y are equal. So these are 3 different options. So we can have a chain conditional statement. Okay. What happens? What do you guys think happens if more than one statement is true? So if true, print 1. Elif true, print 2. Do you think this program is going to print 1, or do you think this program is going to print 2?
Going to print 1 and then it's going to print 2.
That's a good question. Let's try it out.
Or if it doesn't print 1 or 2, then it will print 3.
Let's try this. Let's do
Either 1 and 2 or 3.
if true, print 1, okay? And that prints 1 because true is always true. Elif true, print 2. Oh, it just printed 1 though. We didn't get 2. So when we're using the elif statement, only one of these outcomes can occur. So if true, it's going to print 1. Elif true, it's going to print 2. Else, print 3. So only one of these scenarios can occur. It's a branch and we're choosing one of these outcomes to occur. It is going to choose the first correct outcome. So the first time that it sees a true, that's what we're going to print, regardless of how many trues come after that. Does that make sense?
Yes.
Great. For example, let's make a game. We're going to make a guessing game. I want you guys to try to code this in, or kind of work with this. Yes, I want you to write a program that asks the user for a number and prints whether it is a positive, negative, or 0. And then I want you to modify that program to print even or odd if the number is non-zero. I'll give you a example game here. So let's work with this. You know what? We're gonna code this one here. All right, let's do an example game here. We're gonna import a package called random. We're gonna do import random. That's gonna give us some functionality to work with. We're gonna talk about packages next week. For now, just do import random. Then we're gonna create a new variable. This new variable is gonna call numbers to guess. And we're gonna call random.randInt. We're gonna call a function on random. And that's gonna give us give us a secret number. So this is our secret number, and we want the user to try to guess this number. So we're gonna ask the user to make a guess, and we're gonna store it into a variable called user guess. So we're gonna ask the user, we're gonna call this thing called input, which we've already been working with a little bit. We can collect input from a user. Guess a number between 1 and 10. Let's guess 7. And we can see that user guess now takes on the value of 7. If user guess is equal to number to guess, then print, there we go. then print congratulations. So if the user actually guessed the number that our secret number that we had stored, our number to guess, our secret number that we had randomly generated, then we're going to print congratulations, you guessed the number. But if the user guess is less than the number to guess, then we're going to say, oh, too low, please try again. Otherwise, if they didn't guess the number or it's too low, then we're going to ask them to try again. Okay, I want you guys to write a program that asks, you can use this as kind of your working framework, that asks the user for a number and prints whether the number is positive, negative, or 0, and then modify it to print even or odd. Let's spend at least 5 minutes on this. Okay. I feel like this was our first real coding exercise. How are you guys feeling? Is anybody able to do a program? You know, I realized I stopped sharing these slides. Oh, I can add you back, Tammy. There we go.
Like 6 o'clock.
Okay.
Lyric is a quarter to 8.
I did add you back, Tammy. Okay. Let's go through. How are you guys feeling? Good? All right. Let's go through for loops. The only reason I say that is because I keep looking at the clock. So I wanna go through for loops, and then I want to get through data collections. And I think we're gonna be in a good spot. Then you guys have all the knowledge, all the tools and capabilities, and then we can actually start playing around with this program a little more, playing around with programs more, without having to say quite as much, oh, we haven't talked about what this is. So I want to get through talking about what a few things are, a few definitions, some structure, and then we can start playing with it. That's the goal for next week. So when we bring in packages next week, you guys have all of the tools and capabilities. Okay, great.
Emily, I don't see your screen anymore. Oh, there it is.
You see it now?
Yeah.
Okay, good. I think I had just stopped sharing while we were on the break. Okay. Let's do, we have for loops and then break and continue, and then nested loops, and I think we're done. So we're just going to talk about loops. So there's two types of control structures. We talked about conditionals, and now we're going to talk about loops. So conditionals are if else, it's that tree structure. We're navigating down that street, down that tree. Loops operate a little differently. So
are control structures methods? Or
that's a good question. Are control structures methods? Control structures are not methods. They are built in. I'm trying to use a word that's not methods or functions, because those are very particular things in Python. They're control flows. They're built-in control flows in Python. So not a method. Good question though.
so it's something that's built in and not necessarily a function or method we're building on the.
Correct.
Okay.
So built-in kind of functionality of the language. For loops iterate over sequences. So the purpose of a for loop is to repeat a block of code for every element in a sequence. So we'll say for item in sequence, and the code that is indented into this for loop will execute for every element in that sequence. So I must have this mostly in a notebook. I need to stop sharing real quick because I am on one screen, and let me grab this notebook. This is, we'll move away from the slides now and more into notebooks now that we have some foundational knowledge here. Okay, so in Python and control flow, it allows you to directly execute order which to direct the order in which our code is executed. So we talked about conditionals, if else. We're going to talk about loops and some keywords and some nested loops. So we did we talked a little bit about if else. Let's do conditionals, or let's do loops. Here's our okay, loops. Loops allow us to repeat code until a condition is met for every element in a sequence. So if we have text, we can print text, and if we want to loop over this, we have to say for I in text. We can say print I, and it will loop over every item in text. And it'll print T, and then it'll print E, and then it'll print X, and then it'll print T. And we can, one applied way to do this, tried to tie this to maybe something useful. At the beginning, I'd said, hey, maybe you want to make a shopping list. So we're going to create a shopping list. And we're going to create a list, apple, banana, cherry, and we're going to print, I need to buy, if we need to, sorry, I was trying to remember my example here. We want to print, I need to buy X, and we want to know what we need to buy for all the items in our list. So we say, well, I need to buy apple, and I need to buy banana, and I need to buy cherry. This is a lot of code for us to do. We're repeating the same code multiple times. We're writing the same code. If you're writing the same code more than 2 or 3 times, you should probably find a simpler way to do it. And so the simpler way that we're going to do it is we're going to loop over this instead. So for item in shopping list, we can now say print item. So we can get the same outcome. Sorry, I deleted this. So we can get the same item or same outcome. I need to buy apple. I need to buy banana. I need to buy cherry. Same outcome, 2 different ways of getting that outcome. That's very common with coding and programming, by the way. It's there are many different ways to a solution. There are many different ways that you can get the same outcome and the same solution. This one's better because it's cleaner. It's simpler. Yeah.
Emily? Why is there an F, the letter F in front of the I need to buy?
Oh, that's a good question. So this is a type of print statement. I'm writing that down so we can talk about that in some slide. So this is a type of print statement. In Python, when we want to print something to the console, there's a couple different ways that we can do it. We can print just text. So print, that's just the basic print statement that you guys are used to. If we call print text 1, 2, 3, this is another type of print statement that we can do. The F is a format print. So it's the syntax for a format print is, that gave me the same thing. Anything inside of these curly braces is going to print to the screen. I realize this is a little confusing to use here. I don't have a better way of doing that for this this print statement, but let's just print item. Let's simplify this. Okay, we have our shopping list. I know how to simplify this. Let's get rid of the print statement. Oh, I have the print statement because it's printing our. Okay, that's actually not going to work. It's a format print, so it's just saying if we took the F away, if we take the F away, all of this becomes a string. And sorry, if we take the F away, all of this becomes a string, and it just says, I need to buy item. But we don't actually want to print item. We want to print the actual item. We want to print the variable. And so if we put an F here, anywhere inside of these two strings, in between these two strings, that you see a curly brace on, then anything inside of that is actually code. So this is code that we execute. Does that answer your question?
Not entirely clear.
What the F is?
Yeah.
Okay, the F just makes it a format print. It's a type of print. So there's different types of prints that we can do. We can do a format print. We can do a print where it's going to print this space, and then we can pass a variable, or we can just print the regular text. This is a format print. So it's the syntax for doing a print where we want to leverage curly braces to allow us to print variables within the statement.
Okay.
I did write down when you asked that question off to the side to make a few slides on it that kind of have some arrows pointing to those things.
Okay. That'd be great. And there's like a big blue pill in the middle that's kind of blocking things. It says spend 5 minutes on the breakout, and it's blocking.
I did not take that off. Sorry
it's
about
blocking
that.
Google. Yeah.
It is. I appreciate that. It is a challenge being on one screen here. Okay, so let's keep going through loops. So that's loops. This is, oh, here we go. Syntax for format. Oh no, I just put that in there. So here's some example usage of using that. We can also just print fruits, the fruits themselves, fruits, apples, bananas, cherries. For fruit in fruits, let's print fruit. It's going to iterate over that. If I add peaches, now it's going to print peaches in that as well. So we discussed code that asks the user for a number and to output if they were correct, too high or too low using statements. I want you to now use a loop on that same code and ask the user to input up to 10 times. So modify your code so to ask that asks the user, and they get 10 tries to guess the number. And after the 10th try, report that they are out of tries and in fact just lost the game. You'll use the for loop number of tries to do this. So give this 10 minutes. We'll combine this with our break, and we'll do 10 minutes. We'll do this and the break. I do want to get through the rest of this, and then dictionaries. So, or collections. So let me put the banner up. I will drop this in the Slack so you guys have it. And let me get the let's see, this will be 8:10. Okay. Let's let me share like this. Let's talk about while loops. So we talked about for, and for iterates over a sequence. In while loops, the purpose is to repeat a block of code as long as a condition is true. So for loops will always have an ending criteria. It'll only continue as long as the sequence is. For while loops, the purpose is to repeat this block of code until infinity, if this condition is always true. So that's part of the problem. That's the warning, is that ensure the condition eventually becomes false. When we're in our code, we have to ensure that eventually that it will have a false value, or it can lead to infinite loops in our program, which run forever and ever and ever, and our program will just continue to spin. So I have that in this this notebook. While loops. So an example of a infinite loop would be while true. Let's look at that. It's supposed to print 1, and it does print 1, but it prints 1 for forever. It will keep going to infinity here, essentially. And now I need to oh, this may have, there we go. Now we need to stop this because we saw how long that was getting, and I'm going to clear this output of this cell. So view, clear output. There we go. Okay. So that will run for infinity. It doesn't have any stopping criteria. A maybe different way to use a while loop is to make sure that our condition will eventually evaluate to false. So let's create a rocket launch countdown. We're going to say my value is equal to 10. And while my value is greater than 0, print my value. So we're going to print my value while it's greater than 0. And since my value takes on the value of 10, of course it is greater than 0. So this will evaluate to true. So while true, then we're going to print my value. So the first thing we're going to do is print 10. And then my value is equal to my value minus 1. So 10 minus 1 is 9. My value now takes on the value of 9, and we'll come back up to the top of this loop and we'll say, well, my value, which is now 9, is greater than 0, print my value. So print 9. So now you can see it prints 9. And then we'll go through this and it'll take 1 off and store it back into my value. My value now takes on the value of 8. 8 is greater than 0. You can see that at the end of this, we'll do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then outside of the code block, we print blast off. Let me pause for a second. Does this make sense? Okay.
What tells us how many times we repeat, or is it until the guess is right?
Oh,
what terminates it?
That's a good question. What's the stopping criteria? What terminates it? So my value at the end here reaches 1. So my value is 1. We enter into this cell block. We say print 1. Then my value minus 1 is 0. my value now takes on the value of 0. We come back up to this while loop and we say while my value, which is now 0. So while 0 is greater than 0, 0 is in fact not greater than 0. So this evaluates to false. So this becomes false. And the moment this becomes false, we exit the while loop and we go to this next print statement, because this print statement is outside of the while loop, and we print blast off.
So the false statement is what triggers the blast off. Okay.
The false statement is what triggers the end of the while loop. Yes. So here's a, we can do it the other way. We can set count equals to 0. And we can say while count is less than 5, print count, and we can count up, and we can add 1 to it. So count is 0, 0 is less than 5. So we print 0, and we add 1, it becomes 1. 1 is less than 5. At the end of this ends when count, we come in here, it's 4. It takes on the value of 4. 4 is less than 5. We print count is 4. And then we add 1 to 4, and 4 becomes 5. Then we go back up to the top of the while loop here. 5 is less than 5. This evaluates to false. So the while loop ends. It terminates at that point.
While means as long as, basically.
Yep, while means as long as. Yep. That's a great way to say that. Okay, here's a you try it that you guys can do if you would like. All these exercises are in the Google Drive. Just a quick note on break and continue. We won't spend a lot of time on this. But if you want to end a while loop early, you can break the while loop. So if there are certain edge cases or certain scenarios where you want to end that while loop early, we can say if I is equal to 3, then break, and it'll just terminate that while loop. You can also use continue to skip certain iterations. So if we don't want to break the entire while loop, but we want to skip just one iteration of something, we can use the continue function. Last little nugget of information here. We can nest loops. So we've been talking about loops as just one for loop, but we can nest loops. We can say for I in range of 3, for j in range of 2. Here's the we can have some type of function. So oftentimes we're working with multi-dimensional data. So think about images. Images can be sliced like this, and each pixel maybe represents a piece of information that you want to work with. So pixel A, pixel B, and this is multi-dimensional now because we have 1, 2, 3, 1, 2, 3. So this position here is 3, 1. So there's 2 dimensions that we need to work with in this image, pixels associated with an image. So sometimes we might need to loop over things in a multi-dimensional fashion. Okay. Let's talk about any questions on while loops, for loops, before we talk about Python collections. So our last topic for today, we got through 3 pieces of content. This one's not too terribly long. I just have to move this over. Okay, Python collections. These are some additional Python data types. So far we talked about the ints, the strings, the floats, and the Booleans. This is an extension of that. We're going to talk about lists, tuples, and dictionaries. Here, we're going to make a shopping list. Imagine how cumbersome it would be if every time we had a shopping list and we wanted to print the shopping list, we had to add another item to print. So we say milk is equal to milk, eggs is eggs, bread is bread, cheese is cheese, and we're going to print milks and eggs and bread and cheese. And imagine if we have a new item, such as butter. So new item equals butter. Well, now we have to add this to our print statement. What if we had 300 items? That's a lot of things to juggle. That's a lot of individual pieces to manage. In comes lists, or collections really. In comes collections. Collections enable us to store multiple values into one variable. So the great thing about collections is, in our shopping example, now we have shopping list, milk, eggs, cheese. We put milk, eggs, bread onto our shopping list, and we want to add a new item. We can say shopping list.append. We can add butter, and we can print the shopping list. So we just reduced all of this code. There was quite a few lines in here into just 3 lines of code. So sometimes it's helpful to store more than one data type into a collection of items like a shopping list, so it's easier for us to manage and work with in our code. So we can store data together as, in this case, these are coordinates. This is a list. This is a tuple. Tuple allows us to group data together, like coordinates. And we can store relationships between data. So a dictionary, for example, which is another data type we're going to talk about, allows us to have a relationship between name and Alice and phone and the phone number. So they're key value pairs, and they have a relationship between them. The first one, so collections are a data structure type that allows us to store and organize multiple values into a single variable. The common types of collections that we're going to talk about: lists, tuples, and dictionaries. And the whole purpose for using these is to group related data together, to simplify data manipulation and organization, and enable efficient access and operations on the data. Let's talk about lists. Notice for the list here, the list example, I put 1, 2. This is a string. This is an integer. This is a list. We have a list in a list. This is 4, and this is true. Python lists are very interesting. They allow you to store data types from multiple data types into one list. So what is a list? A list is a collection of items in Python that you can store multiple values into one single variable. So here we have my list, and we're storing 1, we're storing apple, and we're storing 3.14. These are multiple data types, and we're storing them into this value of my list, or into this variable my list. So this is an object that has multiple objects within it. It's a collection of objects. Lists are ordered, so the elements, the order matters here. 1, apple, 3.14. You will always get the same order. So order is stored and accessed in the same order that it was added. Lists are mutable, so we can change them. We can add to them, we can remove things from them, we can change elements, we can move elemental positions. Lists are mutable, and they have methods associated with them that allow you to modify them. Supports mixed data types. So this is a key point that I was saying. Python is a very interesting language, and some other languages don't allow you to have string. Like if you make a list, it has to be a list of strings or a list of integers. In Python, we can have mixed data types here. A couple of key features in methods associated with lists. Accessing elements is index-based. So just like we index in strings, we index into lists. And in Python, everything is 0-based. So this is 0, this is 1, and this is 2. So this is the item at the 0th position. So print my list at 0. What do you guys think this is going to print?
A.
That's exactly it. Yep, we're going to print A here. So in Python and with lists, how you access elements is using these square brackets here. It's how you access something in Python. Okay, so accessing elements, we use indexing to access the elements. Remember we talked about methods. One of those methods we can use is the append method. So list has a append method. And if we have a list that is 1, 2, 3, and we append 4, this is going to enable us to update that data object and add 4 to that list. Removing elements, we can remove an item. We can pop to delete items. We can slice. We can do start and end slicing, just like lists are kind of similar to strings. Just like you can slice a string, we can slice a list. So we can go 1 to 4. So 1 would start here, 4 would end here. So this would output you 2, 3, 4. If we remove 2, this would remove 2. If we called the remove on this, so we would just have 1, 3. And we can iterate over lists. So we just learned about for loops, and we can now iterate over lists. We can say for item in my list, and we can print the item. So we can use we can print the item for each item in the list. It's an iterable object. I want you guys to try it. Let's spend like 3 minutes. I want you to create a list of your 5 favorite foods, and I want you to print that list. Go ahead and add a new food to the end of the list. Replace the second food with sushi. Remove the last food from the list, and then print the first 3 items in the list using slicing. Okay. Spend about 3 minutes on this. I need to pull up our notebook for this one. Just 1 second. Okay. I think I went a little far. Trying to find our You Try It here.
Emily?
Yeah.
Emily?
Yeah.
I don't think we have this PDF that was shared with us in Google Drive.
This, you don't have this slide deck?
Yeah.
Oh,
Yes, that's right.
okay. I will make sure that that is in Google Drive.
Thank you.
I can do that. It might be at like 10 p.m. my time tonight, but that'll be like midnight your guys' time. But I will make sure that's in the drive. I have an event I have to run to after class. Okay. So let's try this. Create a list of your 5 favorite foods. What are your guys' 5 favorite foods? Somebody have a favorite food?
Yogurt.
Oh, yogurt. That's a good one. What else?
Baklava, if you can spell it.
Baklava.
Perfect.
Is that close? I probably butchered that. Let's I do like sushi. What else, guys?
What's the stinky fruit called? Duran? I think it's just Duran.
I don't even know what that is. That's a good one. Duran. All right, give me one more. Oh, did I make sushi? Sushi's the thing that we're working with. I'm going to change this one. Instead of sushi, we will do, we'll just do these 2 that are below. We'll do pizza and mac. So can't go wrong with pizza and mac. Okay, so we have a list of my favorite foods. Great. Now we want to add a new food to the end of the list. So my favorite foods. We're going to call .append. And we're going to add new food. We're going to add a new food. Now let's see what this looks like. My favorite foods. New food. We're going to replace the second food with sushi. So we're going to say, let's try to do my favorite foods. At the second food would be the first index. Because remember, Python is a 0 position index language. So 0, 1. So the second food, baklava, we're going to replace with sushi. my favorite foods. Oh, baklava is gone now. And now we have the value of sushi here. So we're going to use, and then we're going to remove the last item from the list. So we're going to my favorite foods dot pop sushi or new food. Dot pop, sorry, new food. And if we call my favorite foods, we can see that, oh, new food is still there. What did we, oh, I put new food on there twice, my bad. There we go. Now we see that new food is gone from that list. Okay, print 3 items in the list using slicing. The first 3 items. So my favorite foods, we're going to slice from 0 to 3. So position 0, position 1, position 2. And remember, we go up to position 3, but it's not inclusive of position 3. And that will give us the first 3 items. And then we're going to iterate through the list. And well, that was a bonus one, so we'll keep going. Any questions on the list so far? Okay, great. More on lists. Lists are dynamic. They can grow and they can shrink. We can, as you saw, we can append and we can add an element. We can pop to remove the last element from the list. We can print my list. Lists can be nested. We can create multi-dimensional lists like you can see here. There's a few limitations of lists though. They can store mixed data types, which is great, but sometimes that makes processing difficult and inconsistent. And for faster operations, we should really leverage NumPy arrays. Okay, tuples is our next data set. Notice that lists, like this is syntax. This matters. So the syntax with lists, if you use a square bracket, you're creating a list. So if you open and close with a square bracket, you're creating a list. If you open and close a set of objects with a parentheses, with a rounded bracket here, with the parentheses, you're creating a tuple. So a tuple is a collection of ordered items similar to a list. The difference between a tuple and a list is that a tuple is immutable. So the key characteristics here, just like a list, it's ordered, it is immutable. So when tuples are created, we can't modify them. We can't add, remove, change elements. We have to recreate the tuple if we want to do that. And just like a list, it does store mixed data types. So here we have my tuple, and you can see we can open parentheses, close parentheses, and we have items that are stored inside of this tuple. This is an empty tuple. This is a single element tuple. This is what a nested tuple would look like. A couple of key features of tuples, they're immutable. They can't be modified after creation. Accessing elements, we have to use indexing to access individual elements. Here's an example of the immutability one, by the way. They're immutable. So we cannot access, if we say my tuple at 0 is equal to 10, we cannot assign 10 to the value of 1. We can't update and change that. We have to create a new tuple to do that. Accessing elements, this is how you're going to access an element in your tuple. So my tuple at 1. For slicing, we can extract a portion of the tuple. Just the same way that we slice on lists, the same way that we slice on strings, we can also slice on tuples. Tuples can be nested into each other. And there's this, maybe I should call this an advanced topic of unpacking. This is kind of one of the big value points of tuples, is we can actually call x comma y. Notice we have 2 variables on the left side of the equal sign here. We almost always have 1. and we can unpack the tuple coordinates into both x and y, into two different two different variables. Let's look at tuples first, and then we can look at data integrity, etc. Let's actually look at some. So here's a tuple. My tuple, Apple, 1, 2, 3. We can call type on that, and we can see that the type actually is a tuple. If we want to access, we cannot restore these values. Like when string, we tried to change this to a 10. We can do that with a list, I'm sorry, but not with a tuple. Okay, slicing, we can slice into this, nested tuples, coordinates. I think the piece I wanted to add here is that these are separate. So when we unpack this, we say coordinates equals 10, 20. And then we say x, y is equal to coordinates. X and y are their own variables. So x has the value of 10, y points to the value of 20. These are their own variables. We just unpacked one object. We unpack the tuple into two separate variables, which is, I don't know, this is pretty cool. I think it's neat that Python does that. Okay.
Hold on, bring that back again real quick. The coordinates. Got it. Thank you.
It's pretty clever. I see it used a lot in functions, in passing values between functions and information back and forth between each other. So it's used quite a bit. All right. Why use tuples? Data integrity. Anytime we're using an object that's immutable, it helps with data integrity. So it's ideal for storing fixed data. Tuples are efficient, and they can be used as keys in dictionaries because they're hashable. And like I said, honestly, I see them mostly being used as functions in return. So here's an example: def get point. We have a function. Def means means we're defining a function. We're calling this function get point, and it's returning this tuple. So it's returning 10, 20. So I see tuples often used as returns for functions because we can unpack these points from a function when we get those values back out. I have a little compare and contrast for tuples versus lists. If you guys are curious, feel free to use this as a resource, understanding what's the difference. I know that's a big question I get a lot. Like, they look very similar. We use them in a lot of the really similar ways. So hopefully this helps you understand the difference between the two and when to use each. Okay, we're going to keep going from the U, try it, because I want to do dictionaries. And so let's look at dictionaries. Dictionaries are a very different type of collection in Python, and they store key value pairs. And the syntax looks like this, with curly braces and key and value that they're storing. So what are dictionaries? A dictionary in Python is a collection that stores key value pairs. And each key in the dictionary maps to a corresponding value or a set of values. It can map to a list or to another dictionary. A couple of key characteristics: tuples were ordered, lists were ordered, dictionaries are unordered. So order of the elements is not guaranteed in a dictionary. If you're doing something like an efficient search, you probably don't want to use a dictionary to do that. Dictionaries are mutable, though. You can add things, you can remove things, you can change them, you can modify key value pairs. The keys in a dictionary, though, must be unique. So a couple of key features. How do we access things? So if we have this key value pair, name Alice, age 25, we can use the key to retrieve a value. So if you say person at name, what you're going to get back out of that is it's going to return Alice. Let's look at that. Okay, dictionaries. We have my dictionary here, name, Alice, age, city, New York, 25. We can, you don't have to have it all on one line. We can organize dictionaries. I personally like to look at them this way. Makes it a little easier. We can have lots of different content in a dictionary. So header to header text, value to 1, 2, 3, 4. So our keys are always strings, but our values can be anything. It can be a list, it can be a number, it can be another string. If we want to get all of the keys out of our dictionary, we can call mydic.keys and it'll return all of our keys. So header, value 1, value 2, value, it should be key. That's confusing. Key 1, key 2, key 3. There we are. We can call mydic.keys and we can get all of the keys. We can call mydictionary.value and we can get all of the values within our dictionary. So everything on the right side here. So the left side here is the keys, and what separates them is this colon here. So key, colon, and then the value you're storing associated with those keys. The way that we access values in this is if we call person at name. So if we pass a key, you're going to get the value out. So if we pass name, we're going to get Alice. Okay, that's where I was at in the slides. Adding or modifying values. We can add or modify key value pairs or update existing ones. So we can say person at city is equal to New York. So we're adding a new, this didn't exist. We're adding a new key value pair, or we can update an existing key value pair. We can say person at age equals 26, and it will overwrite the value that we had in there for age. Excuse me. Removing items. We can use del or pop to remove a key value pair. So we can say delete person at city, and then it'll remove that key value pair from the dictionary. We can say age equals person at pop, and it'll take that value from age and store it into this variable age. And we can check membership. We can say check to see if name is in person. Dictionaries are a very powerful data type, very powerful data structure in Python. We can access data quickly using names. Oftentimes we want to build relationships between pieces of data that we're working with and have ways of looking them up. And that's exactly what dictionaries enable us to do. Dictionaries map they're equivalent to like JSON structure. They're very similar to the JSON structure, which is used in like API payloads and API communication. So it's really important for if you do anything with networking or if you're trying to serve information up through a service. When you get to the, you'll go through the 3 machine learning courses. You'll do ML1, ML2, and when you get to the API course for machine learning, how you deploy machine learning models into APIs, JSON dictionaries play a really important role in that. I guess I have that. There we go. Storing real-world applications, storing API responses in JSONs. You can also map student IDs to names. Okay, I'd like you guys to try it. I want you to do this. You try it. This will be our last thing for today, and then we'll head out. So spend 5 minutes doing this. You try it. Create a dictionary called student with the following keys. Try to access and modify them. Use some dictionary methods, and then we will call it a day for today. So spend 5 minutes on that, and then we'll come back after. Okay. Let's try this out. Let me share. Just come to the end of the notebook here. Okay, let's create a dictionary with following keys. Name John, age 21, major computer science. So we have a key name, John, comma, age 21, comma, major computer science. We want to access and modify that. So let's print the student's name. Let's print name. Let's update their age to 22. So student at age equals 22. Oh. I did not define that. Oh, print, sorry. Student at name. And that's John, sorry. Student at age equals 22. You tell I'm tired. And let's add a new key value pair, GPA 3.9. So student at GPA equals 3.9. And let's print all the keys in the dictionary and print all the values. Student.keys, student.values. Great. That is it for today. Let me stop sharing. Thanks for going through all that content. And then when we meet, I'm going to drop a few more resources. Oh, I'm going to end the stream here.